Historically, the networking industry has relied on an architecture that involves 2 or even 3 layers. An IP layer that carries IP Ethernet, layer 3, layer 2 services, a DWDM layer that efficiently transports heavy traffic loads, and then in specific scenarios, a separate OTN or optical transport network layer for private line services. Now, as technology evolves, it's good to take a step back and question whether this traditional architecture is still the best fit for the next 20 years. Your optical infrastructure was probably built to handle circuit switch traffic, but since most traffic is now IP data, it may no longer be the best fit. Now, juggling multiple layers of technology can be a real headache, leading to added complexity and higher costs every time you need to make changes or troubleshoot problems. And today's topic comes right out of the Network Priorities for 2023 research report. And of the 4 priorities listed, we already covered this first one, build a wireless strategy. Check that out, the incredible Bob Herbeck. Definitely add that one to your watch list after this show. But today we tackle networking priority number 3, invest in a converged transport network. And we are guided by 2 experts, Tyler Tappy.
Hey, Rob, glad to be here.
He's going to lead us from the layer 1 optical perspective, and with Josh Hogan's help.
Thank you for having us.
They both make a compelling case for convergence at layer 3. In fact, this is one of those rare gems that we all love to come across. More features and capabilities packed into a simpler, compact framework. All right. My name is Rob Boyd. Welcome to TEC37, your home for technology, education, and collaboration from Worldwide Technology. All right, guys, so glad to have you on TEC37. Tyler, let's start with you. What is your background? What are you responsible for?
Yeah, I'm a technical solutions architect focusing specifically on optical. I've been with WWT for probably the last 3 years. And prior to that, I spent 15 years with another solutions integrator doing a lot of the same stuff. Started off doing optical deployments, moved my way into design and architecture, and ultimately I'm here as a TSA, so happy to be here.
Awesome. Well, welcome. So Josh, tell us about what's been your experience at WWT. What are you responsible for?
Sure. So I'm also a technical solutions architect. Tyler and I are actually on the same team. So we are both involved in this, what's called core networking. Tyler mentioned he covers the optical. He's one of the guys responsible for the optical side. My background is all in routing. So I had most of my career, I worked at Cisco, where I went from being engineering and consultancy to architecture, mostly in routing and switching and service provider technologies.
Got it. Okay. So routed optical convergence or routed optical networking, because RON, I feel like we anthropomorphize that a bit when we can use that, an acronym that sounds like someone's name. But when it comes to that, I think despite having covered the topic before, it still remains very relevant, if not more relevant, because of the way in which some things have evolved. And I want to cover that. But Tyler, I wonder if you could kind of set the stage for us. What's the state of the industry right now? What's important to understand about where it's come from and what people are, what's that edge we're coming up to now in terms of having to make a decision about where to go next?
I think it's important to understand like where it was traditionally from a traditional standpoint and then where it's going. Optical transport networks are mostly like their own single domain, their own entity. So it's this single contained system that takes in routers, takes in switches, takes in servers, takes in services like that. So you're taking in all these different functions over something that's, you probably heard of DWDM, right? Dense wavelength division multiplexing.
Yeah.
So yeah, with DWDM, that's what we're doing in a lot of these traditional optical transport systems. We're taking in different wavelengths and services onto a common pair of fiber across the network. So we're able to multiplex many different wavelengths, and we're able to demultiplex them on the other end. So traditionally, optical has used a pair of fiber. So it goes transmit to receive one way, and then transmit to receive back the other way. So it's bidirectional, but unidirectional because we're using 2 separate pairs of fiber, right?
Okay.
So now that we kind of understand, like, okay, so we have a DWDM system, right? And we're able to multiplex many different signals into it and strip them out at the other end. It's creating a layer 1 segmentation of these different services. They're literally their own thing riding on this pair of fiber. So you're able to expand the outside plant capacity of that pair of fiber. And that's really important to operators because fiber is a rare commodity. It's a resource that's really hard to come by, right?
Yeah.
So if we can take that pair of fiber and turn it into 96 different services for them, that's a win. Now you don't have to keep trenching fiber into the ground. You can save a ton of money doing something like that.
And
so
just to jump in on that for real quick, to make sure I understand why it's considered a hard to come by type of thing, it's really because of the trenching, right? It's not that the fiber itself is hard to come by. It's the fact that getting fiber in a situation so that you can then light it and do something with it, that's the big hump. And so when you have it in, then you're kind of limited to whatever you've got installed. And so as efficient as you can be with what you've got to play with is really what you're talking about, whether it's leased or owned.
Yeah, absolutely. Putting new fiber in the ground is very expensive. It takes a ton of time. There's right-of-way access. You have to go across railroads, waterways, just stuff that takes a lot of time and a lot of expense for service providers and enterprises and public sector to do that. So, yeah, it's definitely a rare commodity because it takes so much time and money to do so.
I'm curious, what is involved with doing it in the traditional way most people would recognize or understand it? Because it's optical engineers that are running these things, right?
Yeah, absolutely. So okay. One of the major things that's involved is a transponder or a muxponder. Transponders and muxponders are essentially close enough to the same thing. But what a transponder is doing for us is it's kind of sitting in the middle between, let's say, your router and the DWDM transport layer. So it's able to take in a router on what's called a gray interface, a gray optic. And that's like a short reach multi-mode kind of thing, or a 1310 optic. These are really common optics, but we're able to interface with that gray optic. Then we're able to add a DWDM wavelength to that and then send it over that DWDM optical transport system. So that transponder is a really, really nice piece of hardware because it's a clear demarcation point for service providers, for example. So this is their handoff. I know that from here going this way to over to my router, this is going to be their problem. And here off of the transponder on a DWDM wavelength going over my optical network, that's my problem. So it's really nice for them to have that clear distinction. And that's why it's run so well for a long period of time. With those transponders and muxponders, there's things like protection switching services. So protection switching's been very important for optical for a long time, sub 50 millisecond switching, right? So you have these transponders and they're either cabled in a certain way or fibered in a certain way where if one path has a failure, the other path is going to take over sub 50 millisecond. Okay. And then finally, with these traditional optical transport systems, you have the ROADM functionality. So you have your DWDM capabilities, you have a transponder. Now what can you do with that? With ROADM, which stands for Reconfigurable Optical Add-Drop Multiplexer, big, long, scary acronym. But what you can do with ROADM is a perfect example is like site 1, 2, 3, right? So if I have a service at site 1, a router, for example, that I want to send to site 3, you can use what's called pass-through functionality, which is what ROADM gives us to be able to send that light through site 2 without having to drop to any extra routers or any extra optics or any extra components within site 2. So ROADM allowed us to go from one site through many sites to its end destination without having to waste resources in things like optics and routers, etc.
Okay. Because you want to minimize the number of times you're having to translate that signal because you're doing a digital to analog conversion essentially to put it on the wire. I shouldn't say it that way, on the light. The light is considered analog. Well, in that situation, Josh, I'm going to turn to you just because I think this would come from you, but what is your role if you're responsible for the network side of things, the IP layer in what was just described? How has that been handled traditionally?
Yeah, and this really starts to lead into, what is converged networking and what do we do with it? I'll tell you myself as a routing guy, prior to coming onto this team, working with great architects like Tyler, the transport network to me was a bit of a black box. And I think that's the case for a lot of routing guys who come with a strong IP background is you get your plug, right, coming in, whether it's 10 gigs, 100 gigs, whatever's plugging into your router, and then you can route with it. You can set up all kinds of services, but whatever's happening out on the line, you're not really familiar with the technologies, the different capabilities, all of the services and things that it can do as well. So it's a big part of the background of this equation is when you think organizationally, you have a lot of organizations that have strong IP engineers, strong optical engineers. Sometimes these are totally different teams with just different outlooks because of the different technology that they work on.
Yeah, well, so the demarcation that's been used historically is something you're used to, which is just, okay, well, that's the point where I don't have any control over it any longer. And that's where Tyler and his peers are taking over and they understand what's going on, but they may not fully understand what you were doing on your end. And everybody's fine as long as we knew right where to hand off, begin and end. And it's a system that's worked well, right? Customers have been doing this for quite a while. But you guys have been on the on your soapbox saying, "Look, there's a ton of benefits to doing things in this converged fashion." Does it make sense based on what you've said so far to say, "Okay, well, tell me about what's starting to change and why"?
You kind of have to understand where some of these traditional systems might fall short. If all you're doing with your optical transport system is lighting it with routers, essentially you're falling short, because what you can do with convergence is we can take that functionality out of the transponder and move it into a pluggable optic within the router itself. So if all you're doing is just lighting that optical transport network with routers regardless, why not just eliminate that layer? And you could be much more efficient by just bypassing that transponder altogether, I would say, is one.
Well, so Josh, let me ask you, if we're putting a transponder now in the router, it's no longer a separate, distinct device. How do you feel about that? What does that mean? Does it change how you look at things?
Well, it definitely changes the capabilities of the network. And Tyler referred to a couple of them. There are many. The 50 millisecond convergence that the optical network is capable of. With routing, we've always done that with different protocols. A common one that people know would be BFD, or bidirectional forward detection. Very common layer 2 functionality on routers, where we can detect failures between the routers. So a lot of this type of stuff starts to get offloaded and put on the routers. And really, when you get in depth on the services, which would typically be provided by the different DWDM wavelengths Tyler was talking about, or even by ROADM, all of those services now can really begin to get serviced by MPLS and segment routing. And you start to get into being able to use, on a hop by hop basis, with your bandwidth management coming from this optical convergence, you start to really get into being able to use some of the functionalities of MPLS services that have a lot of power, the traffic engineering, loop-free alternate, flexible algorithm, all the way to like network slicing, which is right now becoming very popular in the 5G and wireless spaces. So it opens up a lot of doors, because all of a sudden you've combined two capabilities, and you have a lot of this stuff which has been done on both now residing on one, kind of simplifying the process and adding more power, if that makes sense.
Yeah, no, it makes a ton of sense. But also, just to make sure, because does the ROADM go away in that situation?
Yeah, I think the answer is maybe. It's totally
Awesome.
dependent on the customer architecture, what the customer is doing, right? So if you have a need for just maintaining routers over an optical transport system, sure, that makes tons of sense. If you have a need to transport something like alien wavelengths from site to site at a true layer 1, because maybe you're a service provider in a strategic location, you have access to one of the major internet uplinks like Ashburn or 60 Hudson in New York or whatever, they're all over the country.
Yeah.
If you have access to something like that, you have a hot commodity. So you might have a layer 1 transport need with something like a transponder or muxponder for banks or data centers or whatever. So there's definitely both situations. It's just very dependent on what the customer's doing with their network.
I got you. Good old engineering answer. I like that. It depends. But I also think if we're now putting that on the router, you mentioned pluggables. Tyler, how has that evolved? Because obviously they're a lot smaller, it sounds like, and their power needs must be changing. What does that do to distance limitations? Can you give us an overview with as few acronyms as possible in that kind of conversation? But yeah, what's happening there? I don't mean to tie your hands with the acronyms. Use as many as you need.
I'm gonna lead right into acronyms.
All right, go ahead.
So I think the big thing is understanding what coherent is and what coherent gave us. So coherent, basically, there's a local oscillator on these lasers, which allows you to dial to exactly what you want to, and then you can compare the difference when you modulate on phase. This is a lot of optical talk, and I apologize, but overall, it's very complex with coherent, more so than with regular standard optical transmissions. The way optics can allow you to get data is basically if you see a light or you don't see a light. It's bright, dim, bright, dim, bright, dim. You can translate that into ones and zeros, but coherent is so much more complex than that. It's all done by something called a digital signal processor, which is a chip that used to sit within transponder cards. What we've been able to do with that DSP, these DSPs are very advanced. They're almost like modernized CPUs. They're not quite there, but they're definitely up there. We were able to take that, and I wasn't able to take this chip, but the manufacturers are able to take this chip, shrink it down, and then put that onto a plug. So when coherent first came out, we immediately jumped like tenfold of what we could do in optical networks. We were always constrained by things like dispersion and OSNR, Coherent gave us that ability to go long distances without the need for regeneration. So to summarize, the real magic behind it all is that DSP and being able to shrink it down, put it on a pluggable optic. Those pluggable optics have come a long way. We started off with CFP2, which is kind of like half the size of your cell phone, I would say, in length and width. And then we went down to a QDD plug, QSFP DD plug, which is what we're rocking right now. QSFP DD, ZR, and ZR Plus have been really good hot optics for the past year or so, especially for Josh and I. We've done a few customers with this specific pluggable optic. We've written case studies on this stuff. It's been really hot. The downfall with the current generation of that is that it's coming out at about neg 10. That's really low light. Traditionally, we're used to transponders coming out at about 0 or plus 1 dB. So in the next iteration of QSFP DD ZR, ZR Plus, there's going to be something called Bright ZR. That has an integrated amplifier in it. That's going to take care of the problem that we have with that low launch power. So now we're able to launch into things like contentionless networks, CDC networks. We don't have to amplify as much anymore. So we're able to integrate extra amplification into the plug, and then we don't need as much external amplification, amplifiers and chassis and stuff to launch that thing further. And then beyond Bright ZR, we're talking 800 gig and 1.2 terabit. I presume those are going to be very much like their predecessors, where we're just going to have better modulation rates at every speed that comes out. So we're just going to be able to launch further better.
So from the router side, the evolution of the optical capability when it comes to that DSP, this starts to become really critical, that you kind of have magic happening on both sides that's really pushing this converged ball forward. And what I mean by that is, Tyler talked about we've currently landed on QSFP DD, and that's specifically QSFP 56 DD. Routing people will be very familiar with QSFP 28, which is really your standard 100 gig. Well, the nice thing about this, as compared to what we've been using so far, which is CFP2, CFP2 is kind of clunky. It's an awkward shape, draws much more power, much less power than a transponder in, a typical optical box, but less than QSFP-DD. And the biggest single most important thing is that all of the router vendors now can standardize on QSFP-DD and just throw these ports under. So the density is really starting to explode. At the same time, you have routers with, kind of standard ASIC capabilities. So you're not talking about super advanced investments into the actual chips on the router, but you can still push a lot of throughput with high density of these ports. So these ports are backwards compatible to the 100 gigs, even all the way down to like 10 and 1 gigs, and you can break them out. So it's the incredible amount of flexibility and density that you get from this particular version of a port that is kind of just sweeping across all the vendors, and suddenly the industry seems to have really landed on this and said, this is the way we're going to do it.
But am I understanding correctly that you're saying that the optics themselves are also driving additional life into the routers that they sit in, so you're getting more out of your existing equipment to a certain extent, maybe?
Yeah, just to give a very simple example, today we're shipping out 400 gigs using ZR Plus. So this is a QSFP-DD form factor, but it's running ZR Plus technology at 400 gigs. That's about what we're doing today. Most of the deals that Tyler and I are working on and helping design, it's 400 gigs. The future, which is right around the corner, is going to be 800 gigs, probably using this Bright ZR technology. But again, it's improving the optical capability. The form factor gets to stay the same. So we have a lot of vendors which are designing the throughput, the fabric, the backplane of their boxes, whether it's chassis-based or non-modular and fixed. They're designing that so that these ports can go up to 800 gigs, which it will very shortly, or even beyond. So there's a lot of investment protection.
So because of the router improvements in the router ASIC design, as well as what we're doing here to consolidate or converge, I should say, use the same terminology, you guys have written about sustainability. And I always hate to throw that up in terms of, because it feels like it's an abused term these days. It's certainly hot to talk about. But anytime you talk about reducing the number of things that have to be plugged in and that are and use God knows how much power, there's got to be some benefits as these things get smaller. What kind of things are you guys seeing? And are customers do customers actually appreciate those that part of the advancement as well?
There's a lot of long-term investment conversation that goes into it, and it's good because this is a popular conversation right now. I think it's really just in the last couple or maybe last few years that you have most large organizations really starting to consider this more seriously. And it's easy to say, okay, we have power savings. Let's measure the power savings for you. It's easy to show space. So you're cooling less. You don't need as much rack space, not as much infrastructure. Those are all straightforward. Some of the things that have surprised me just to think through as we've actually gone through this experience is, yeah, why not? There's less to ship. So there's less cardboard associated with the logistics of getting this gear from point A to point B. The management, it all becomes streamlined and more efficient. So a lot of it is, we will work with customers, and a lot of times on projects, we're trying to put numbers on paper to get a good grip on what this really means. We don't like it to just be talking points. We want to make it rather real. But there are so many downstream benefits of the sustainability that it's almost becomes hard to quantify.
I want to talk about we talked a little bit about MPLS and segment routing. What do people need to mentally be prepared for in terms of the positive benefits I get, but what's my transition like in the meantime?
Yeah, organizationally, there could be challenges to work through, but the way I like to look at it is, fundamentally at the end of this, you still need both skill sets. You need people who understand what's going on the fiber to actually make it work. It does require architecture, engineering, implementation, et cetera. And on the routing side, same thing. We're going to be routing packets, providing services, dropping that at layer 3 and layer 2. So that all still needs to be there. So the big question is organizationally, where do you strike the balance? And just speaking for myself, I think this is probably the same for Tyler, for others on our team. We come into this converged experience with our own background feeling kind of siloed. I talked earlier at the beginning of this about how, as a routing guy, I like to just take the plug and then I want to route. I don't know what happened. What do you guys do? That's a black box to me. Now I know so much more that it actually improves my ability to help architect the network at the layer 3 because I'm considering all of those factors that are out on the optical network. So even though I'm never going to be an expert like Tyler, when it comes to routing, he'll never be an expert like me. We're getting closer to one another, and that's improving overall the architecture of the network that we put together.
I'm curious about latency in this versus the old model. Do you have to put any customer's mind at ease in terms of the ability to not have that negatively affect their application that they're used to or that they're driving for when we do that?
It really goes back to the question of the router capability, the port standardization on QSFP-DD, as well as the optical standardization improving. All of these things are happening together in a really mutually beneficial, positive way. Having the chipsets now that can move packets in and out so quickly at layer 3, and especially when we layer on MPLS, and so you're doing this fast switching from site to site, it's really able to handle this load where you're not inducing all of the latency at all of those hops that we may have just a few years ago. So I think this may have been a concern that, it needed to be worked out, but as all of these things came online, the router capability, the ports capability, the optical capability, and certainly using MPLS and all of the things that MPLS can do today, that's all improvements in latency that keep the packets going from A to Z as quickly as possible.
Tell me about the benefits of MPLS, and then what is segment routing? How does that play with it? And because I'm also curious, not only understand the technologies and what the importance is there, but is that something to be worried about in terms of knowledge?
When you look at MPLS, sometimes that will frighten some folks. I look at MPLS fundamentally as all it's doing is fast switching packets. So instead of doing a router table lookup, we're kind of just doing a fast lookup on a much shorter, much smaller part of the header, which is the MPLS header. So it's like we've put a little shim on every single packet so that instead of popping open the IP header and getting into all the fields associated with IP and making decisions and potentially having packets get punted to the CPU, we're really just making decisions on this little shim. And realistically, it's just a number telling us what to do. So we can really simplify our router operations. And then because that's happening and your IP field is protected and not being looked at, you now can differentiate services in all kinds of magical ways. You suddenly are able to hide what's happening at the IP layer. So you can give different services to different customers, different things that you need to do. So it's been very powerful. Segment routing, very simply, combines what the routing protocol should be doing with what MPLS should be doing and gives us very fine control over how that works. So it's really just an advancement in our ability to control the way MPLS is moving packets. A lot of times folks get hung up on segment routing because they think, well, if it's more advanced, it must be more complicated. And the truth is, for most organizations, you get massive benefits by just turning it on, and turning it on as simple as like 1 or 2 commands. Given all of the protocols you already have, 1 or 2 commands, turn it on, and you get instantaneous benefits like fast failover in certain scenarios. It calculates backup paths ahead of time, which traditional routing won't do. So all of these things, there's a nice easy transition that could be had, but those are the types of things that make this a powerful journey to get into.
There's a major simplification which has all those cascading effects of lower costs, easier to manage, easier to understand, less things to go wrong because there's just less things in the path. Am I getting that right in terms of some of those? We don't want to overlook the simplification of this entire structure.
What I can say for me on the routing side is I put a very high premium on simplifying some of these functionalities, because you get into more and more config, more and more capability. You start to sometimes blur that line of, well, now there's a lot to troubleshoot. There's a lot that could go wrong. And really what's happening with these technologies is they're actually making it simpler. They're putting so much of this into really advanced software algorithms where from a user perspective, you can just simply set policy. Policy can go out and be enforced on the network. You can maintain it and manage it relatively simply. So I'm always leaning in that direction, is trying to simplify not just what you have to do on the routers, but also simplify your day-to-day. How are you operating and maintaining this network? But that's strictly from the routing side, which that's going to happen either way. You're probably at some point you need to, invest and do this routing thing, MPLS segment routing. When you have a true core network that's providing services like that, that's the direction you're headed in.
So Tyler, let me ask you though,
Sure.
Is the ROADM gone, or is there still a role for the ROADM?
I wouldn't say the ROADM's gone, not even close. There's still awful lot of research and development that goes into that stuff, and there's still an awful lot of folks that are using it. It's just situational dependent. If you are an operator who wants to leverage alien wavelengths, delivering something like that on a layer 1 service, I'm working on a customer right now who has an MRV transponder for one customer and a Cisco router for another customer. They're taking in all these different alien wavelengths into their ROADM today, and they're looking for a new ROADM layer because theirs is old and legacy and it needs to be updated. It needs to support 400 gig ZR converged network solution. That whole infrastructure is ran on an MPLS core. That's one part of their business. However, the other part of their business is handled in alien wavelengths. They're sending other service providers through their footprint. They're connecting data centers. They might be connecting banks. They're doing things like that. Those folks want to be connected on a truly layer 1 perspective. So their network's kind of a hybrid. They have a RON architecture for anything that's broadband residential internet type stuff and business internet. And then they have a ROADM doing transponders and muxponders from an alien wavelength perspective for those customers who want to be connected straight layer 1. So it's like you can see, it's very dependent on what you're doing and how you're operating.
If they've invested in a ROADM, it obviously depends on what they're trying to replicate or create. But in general, how much are customers looking at having to forklift out gear?
What Josh and I see a lot of are customers with old legacy optical transport systems. Sometimes those are just aged end of life. Sometimes those are using an old antiquated way to do like layer 2 switching on an optical DWDM blade that was very popular for a period of time. It was frankly a game changer like 15, 20 years ago when you could take a blade, put it in your ROADM chassis, and allow it to do layer 2 switching with a couple of 10 gig ports on it being your trunks and then a bunch of 1 gigs being your handoffs. But, their old layer 2 switching is kind of bad. And there's just a better way to do it. And customers know that. So they're coming for a change in that regard. I would say another reason that people are looking to upgrade is frankly, they're out of bandwidth. Their system might not be able to handle the bandwidth. They're looking to go to 400 gig. And some of these old optical transport systems are not just going to be able to take in a 400 gig wavelength at 16 QAM and the baud rates that we require to be able to send that over these old legacy systems. So they're in need for an upgrade for sure.
It was harder back when we were CFP2 was really the foot to put forward. And also the routers weren't quite where they are now today. Again, going back to this merchant silicone, these chipsets, which very cheaply allow the vendors, and many of them, they're making these boxes that are highly flexible, highly modular with QSFP DD ports that can do all of this stuff up to 400 gigs, pushing this over 100 kilometers. That capability of flexibility, I think, is really starting to snag a lot of customers and make them realize, okay, the scale is there, let's jump, because this is going to be way more than we need for quite a while. By the time we get there, the advances are going to continue. We're going to just continue to jump. So I would say, in general, I think that routers are pushing a lot of this in terms of their capability.
I wasn't even thinking of that. When customers are coming to us and they have a handful of 1 gigs, they have a handful of 10 gigs. By the way, they want to try and incorporate 100 gig optic. These routers are getting so flexible and just being almost backwards compatible to the different bit rates that the customers are looking to deliver. Whereas the optical chassis, it's just not that easy to say, okay, I want to do 10 1 gigs. I want to do 10 10 gigs. I want to do 4 100 gigs. In routers, we're just able to deliver all of those different speeds and feeds within the box. And oh, by the way, we're able to oversubscribe on all those too. So your cost per bit goes down as well. So I would say that's another huge reason why routers are becoming so popular.
But when we say route everywhere you can, route them if you must, I think I got that right. Essentially, it's like the routing everywhere you can, switch if you must, or is it switching everywhere you can, route if you must? I think I got it backwards. Yeah.
It depends on when you said it, because a lot of people used to, if I go back to the beginning of my career, switching was certainly preferred. Nowadays, there's no question about it. Everybody wants to route all the way down to the access layer, all the way down to your handoff to the end user. So certainly it's very apt to take that and use it for this situation. Where
let me ask you guys about the services that you provide and your experience.
If we're doing a workshop or something like that, what we're looking for from customers is just kind of an overall conversation for the most part. Like, we'll usually start workshops off with a goal and objective of explaining a topic. It can be converged, it can be optical, ROADM, stuff like that. But if it's converged, we're usually looking from the customer some type of documentation on their network, their sites, their services, things like that. And then it's a general conversation just around, what's your business model? What do you do to make money? What's your service that you offer or provide?
I'd kind of make it a little bit of a WWT pitch in that I really just, not only do I love my job, I love the way our team is structured. The fact that, this converged stuff, it really is becoming big. We're doing a lot of it all the time, so we know it and we see it. But it's the fact that our team combines optical expertise and routing expertise. It's always going to be somewhere in that balance that the organization needs help along this journey. You probably have a lean one way or the other, or the previous architecture of your network that you're trying to move off of leans one way or the other. And so you need to develop skill sets to get you fully converged. So the fact that our team combines these skill sets really well, and we're both all available, we're working together all day on all of these different architectures that we're helping people build out there, I think it brings a lot of power to these conversations that we have. And then as we set up services, the communication is just very smooth and effective, because we're always going to have that correct expert in the room who knows what needs to be fit in place there. So really, when you get down and dirty about it, these services look like potentially training, implementation, a lot of proofs of concepts. We could talk all day about the Advanced Technology Center and everything we do in there. That could be its own podcast entirely. But really, I think what's causing us to be successful with this, and why I personally enjoy it, is our team structure just really fits and makes sense for converged. Because again, we have optical experts and we have routing experts, and that's really what you need to be successful in this game.
And it sounds like that may become kind of a structure that you're also encouraging customers to kind of slowly morph into as well. What's most important from your perspective that you'd want people to walk away with? Tyler, I'll start with you.
I just want to say that I think a converged network isn't a one size fits all. I think it takes a conversation, a discussion on what our customers are doing in their day-to-day, what their business case model is. If they're, generally going from router into optical transport or not, if ROADM makes sense for them or not, if they're taking any wavelengths as a service or not.
Excellent. Josh, any final comments from your perspective?
When I look at the fact that we're sitting at 400 gigs right now, really 800 gigs right now, and we're ready to go to 1.2 terabits per second across a single pair of fiber on a pluggable out of a router, that's the coolest thing I've ever heard. The fact that we can do that today, it really blows my mind, thinking across my career and how far we've come. So yeah, it's a little bit of a nerd out for me, but I think if you dive in and you start looking at this, you'll understand the powerful impact that all this stuff brings to your organization. So I think it really starts by just digging in. So go to the wwt.com platform. You can see what we have in the ATC. You can see what we have in the way of Converged. There's different types of topic pages, articles, all sorts of stuff like this. So just jump in. Don't be afraid to reach out to us, have a conversation about it.
Well, perfect. Josh, thank you so much.
Absolutely. Thank you.
Tyler, thank you so much.
Thank you, sir.
Things are moving really fast in this space, and there's a lot to take advantage of here. Josh and Tyler both mentioned some resources to check out, and you're going to find links to much of that, if not all of it, in the information box below. I just want to point out that I found a ton of value on the community page. Now, if you're not sure where to start, a briefing is the perfect first step, but you can also request a workshop, or you can pick from a wealth of other options, including hands-on, physical, or virtual. It's unlimited, and you need to take advantage of it. But finally, don't forget to check out the rest of the research report, Networking Priorities for 2023, to see how all of this fits into your plans for success this year. Well, I hope you enjoyed this one.
I think it was great. You did a great job, man. Josh, good job. I think it went really well.
My name is Rob Boyd. Thank you for watching Tech 37.